let's go through how to write functions that are parallel, perpendicular, coinciding, or intersecting. So we have 4 types of lines. And so we have to know like what the pattern is for each. Sometimes even when I'm doing this, I like make a little note to myself about what each means. And so parallel lines have the same slope, so same m, but a different y-intercept. So same m, different b for parallel. Perpendicular is opposite reciprocal slopes, so opposite reciprocal m's. Coinciding is the same everything. And intersecting, I like to just make it completely different, although all you really need to do for intersecting is make sure it's not parallel. As long as it's not parallel, it intersects somewhere. So parallel lines have the same slope but a different y-intercept. So I want to keep 3 the same but change -4. So I have 3x and then any number I want. Perpendicular, we have opposite reciprocal slopes. So I need to take this m and I need to make it its opposite and reciprocal. First thing is opposite. Since this is positive, mine needs to be negative. Now for reciprocal, it means I need to flip it. Since this is not a fraction, I'm going to make it a fraction so that I can flip it upside down into 1/3. And then for perpendicular, you can have the same m, you can have a different, the same b, a different b, it doesn't really matter. So I'm just going to use this +10 that I used for the previous one. So y equals -1/3 x, and then whatever you want. Coinciding is the same everything. That means it's the exact same line, so just rewrite what was there. And intersecting, technically as long as I don't have the same slope, I can do anything for intersecting. I just like to make mine completely different because I know that that's going to intersect and it's not going to be one of these ones. So I'm just not going to use 3 and I'm not going to use 4 and I'm not going to use -1/3. So I'm going to do like y equals 15x minus 1. Completely different m, completely different b. This would be intersecting.